Please open 8.3 testing a claim about a mean. I hope you used last night to practice testing a claim a little bit because the concept is pretty much the same. Now we are testing a claim about a mean. And I put two calculator command, one when sigma is unknown and the other one when sigma is known. Let's download 8.3 PowerPoint. I quickly go over that because it's more of using examples. And because we are not using formulas, not every single page of PowerPoint will be used. So there are two parts to this lesson. So you are testing a claim about a population mean. Part one is when you're dealing with realistic and commonly used case of population standard deviation, when the population standard deviation sigma is unknown. So realistically, you probably don't know what is the population standard deviation. That's when sigma is unknown. And then there is another part that sometimes is used, very rare, when sigma is known, when you know the standard deviation for population. When that is unknown, you know S. It's easy to know S because that comes from, it's a standard deviation of sample. But then sometimes you don't know, or many times, or it's very rare to know sigma standard deviation for the population. Okay, so that's our lesson for today. We're gonna test the claim. I'm gonna give you calculator commands when sigma is unknown, which we do that much more often, and when sigma is known. Okay. Exactly like interval. When sigma is known, you're thinking of something having z in there. When sigma is unknown, having t in there. So I would say that the test statistic t involve t when sigma is unknown anytime, every time. And then sigma known, z. Please make a note of things that I wrote here. Let's move on. Okay, test a claim about population mean. In the previous section, we talked about population proportion. So we had x and n and p hat. In the previous one, we had p for population proportion. We had p hat and so forth, x, and in this case, we're going to talk about mu, that's population mean. We talk about x bar, which is sample mean. We may need S, that's the standard deviation. We may need N, that's the sample size. Okay, and so forth. But population proportion was our lesson for 8.1 and 8.2. 8.1 was more general, maybe 8.2. Okay. Go to the next. Testing a claim is, I see a question. So testing a claim is when you want to find the p-value and compare p-value with 5% or 1%. So someone asked about p-value. So every time you're testing, we use our calculator to find p-value and we compare it with alpha. Compare with alpha. Large p-value, you fail to reject a null. Small p-value, you reject a null. When you reject a null, you support alt. When you fail to reject a null, you do not support alt. If alpha is not given, is 5%, 0.05. But sometimes they tell you 0.10, sometimes they tell you 0.01, and so forth. Okay. Here are the notations: n, x bar, s, mu x bar, and so forth. We don't need the formula. We're going to use our calculator. Okay. Requirements is either normally distributed or n to be greater than 30. So requirements are normally distributed or n to be greater than 30. Please write down the requirement: normally distributed or n greater than 30 for the mean. So, and as you see, for population proportion is success and failure greater than 5, and n to be greater than 30 or normally distributed for all of the testing involved mean. Okay. So let's use this example. Can I have a volunteer to read this question, please?
Example, adult sleep. The author obtains times of sleep for randomly selected adult subjects included in the National Health and Nutrition Examination Study, and those times hours are listed below. Here are the unrounded statistics for this sample. N equals 12, X bar equals 6.83 hours, S equals 1.99 to 4 hours. A common recommendation is that adults can sleep between 7 hours and 9 hours each night. Use a p-value method with a zero point zero 0.05 significance level to test the claim that the mean amount of sleep for adults is less than 7 hours.
Thank you. So look at the claim. We start writing step 1 through 4. So the claim that the mean amount of sleep for adults is less than 7 hours. So let's just take a picture of this page because we'll be using the numbers. So please take a picture. Someone gotta read it to me when we get there. Especially a list of these values and also the claim. Okay, let's just go to OneNote. So step one is writing the null hypothesis and alternative hypothesis. Step two is checking the requirements. Step three is finding the p-value and writing the calculator command, what calculator command you're using. On the test, don't say just calculator. Tell me what command you're using. We're going to tell you what. And then the step four is writing the conclusion. So let's get us started. The step one, as we said, null is always equality. We are writing about population. This time is about mean, so we use mu. In the previous section was about proportion, we were using p. This is about population mean, we use mu. Okay. It says, the claim says that the mean amount of sleep for adults is less than 7 hours. Less than 7 hours. So greater, less, not equal to is alternative hypothesis. Always equality is null. So this is our null, this is our alternative. We assume this is a normal distribution because it's not more than n is not more than 30. There are how many numbers? There are 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So there are 12 numbers. It's not greater than 30. We assume that it's normally distributed. Okay. So now we want to find the calculator command. So the calculator command here, you don't know, so sigma is unknown. They didn't tell you what is the standard deviation for population of adults sleeping. So sigma is unknown. So you're gonna use t-test. If sigma unknown, you use t-test. Sigma known, you use z-test. Again, every time involves sigma known for any of the calculator command involving mu. When sigma is known, we use z-test, z-interval, and so forth. Okay, so we go to t-test this time. So grab your calculators. Let's go to the calculator. So go to stat, go to t-test. Do you see you have data versus stats? In this case, they also gave you stats, but then let's just use the data. So if you want to use data, you need to introduce your data to your calculator. So go ahead and put the data in L1. So can someone read the number of hours to me, the one that it's in at the bottom? Does anyone have it in front of them?
4844
Give
6
me a second. Let me just write that. Say it again. Hold on a second. Four.
8448.
Oops. 4, 4, 8. Uh huh.
6977
6977. Uh huh.
1078 or 1078. I don't know. Yes, 1078.
Oh, I was thinking one is pretty low. 7 and then 8.
Yeah.
Thank you. Okay, so let's go to stat now. Test, t-test. You have the data. Mu naught is the same thing as the null hypothesis. We said it's equal to 7. You all need to write out the steps on the way that I put it on OneNote as of null hypothesis, alternative hypothesis. List is in L1, there is no frequency. And in this case, we had fewer. We said fewer or less is the middle one. As you see, it says mu less than mu naught. We said it's 7, so mu is less than 7. And this is more, and this is not equal to. Okay, you go down. As you see here, mu less than 7. This should be matching. This should be matching your alternative hypothesis, which is mu less than 7. P-value is 0.38, so 0.388, which is like, let's say, to 3 decimal places. So that's p-value. Or you can round it to zero point 0.4 if you want in this case. Okay, 0.389, 0.389. Give me a second. Put the charger. Okay. 89. Then compare this with 5%. This is definitely greater than 0.05. So when it's greater, I have, tell me which one it is. Reject a null or fail to reject a null. Send
Fail
me
to
with,
reject the null.
say it again.
Fail to reject the null.
Very good. So it's fail to reject a null. And you do not support the alt. So fail to reject a null and don't support alt. And let's write the conclusion. You would say there is not, because we are not supporting the alternative, there is not enough evidence to support that adults sleep less than 7 hours. And then you can always use the last sentence in the claim to form it. The mean amount of sleep for adults is less than 7 hours. So you can just say that, but you can say that there is no support for it. Okay,
Can I see the calculator numbers you got again?
sure. Do you see that? So I want all of you to have matching numbers before we move on. Any questions? Okay. Let's go to another example. So they use TI 8384 calculator. No matter what devices we don't use them, but TI 8384, same p value as we found. Okay. So let's do another example. Let's go to the textbook. Um, we also had, let me just tell you something about confidence interval that you may see on the homework. If you see left tail or right tail test, so in this case, do you see that you have, so let's just go to OneNote. So in this case, if you were thinking of left tail or right tail, which one would have that been? Mu is less than 7. So if you remember, I gave you definition of right tail and left tail last time. So we said if it's less, then the left side is, so that's for less, and it's left tail. If it's not equal to, then it's two-tailed. And if it's more, it's the higher side. If it's more, and it's right-tailed. If they say compare with 5% alpha, the way you find the confidence interval is 1 minus 2 alpha. So tell me, if alpha is 5%, use your calculator. 1, oh my god, my pen is acting. 1 minus 2 times 5%. Tell me, what do you get? So left tail, right tail, two tail. Someone asked if I repeated. So if you are comparing with 5% alpha and you want to find a confidence level for interval, given alpha, then you would say if it's a right tail or a left tail, the confidence level is 1 minus 2 alpha. Which, very good, a lot, Eli, is 0.9 or 90% in this case. If it's two-tailed, it's just 1 minus alpha. So it's 1 minus 0.05, which is 0.95. So depending that it's one tail or two tail, then the corresponding confidence level, oops, the corresponding confidence level is 1 minus 2 alpha, 1 minus 2 alpha, or 1 minus alpha. So in this case, in this next example, if I was asking you find the confidence level for find a confidence level for amount of sleep. So if I was asking that, confidence interval for sleep amount or sleep average. If you remember, for confidence interval, we go to, that was chapter 7. We go to stat. You don't need to memorize these stuff, but so it's, you don't have sigma known, so you go down to number 8, and that's T interval. You have data in L1, and then corresponding in this case is 0.90 because you have 1 minus 2 alpha. It's left-tailed only. So then you go here, and here is the confidence interval. In average, so we are 90% confident that adults mean amount of sleep is between 5.8 to 7.9 hours. 5.8 and 7.9 hours. We are 90% confident that adult mean amount of sleep is between 5.8 to 7.9 hours. Okay, and how do I know 90%? Because they said compare with 5% in the question. How do I know 90 again? So because they said alpha is 5%, and I know the claim was less than 7 hours, I would say 1 minus 2 alpha. If it's right tail, left tail, and then that's 0.90 when you replace alpha by 0.05. If it was two-tailed, then it was just 1 minus alpha. Hope that makes sense. I try to give you the confidence level in the test, but you will see them on homework. Okay, where you need to find it yourself. Let's just do one more.
And that's for if we have the standard deviation.
Say it again.
That's for if we have the standard deviation.
Yeah, that's when you have, that's when sigma is unknown. So for none of these, you had sigma unknown, means you didn't have, when they gave you the number of hours people sleep. Let's go here. You have S, but you don't have sigma. Sigma is unknown. Sigma is a standard deviation for the population. If sigma is unknown, then you use t-test. It's very rare that sigma is known. If sigma is known, that again is very rare, then you use z-test. Okay? Okay, let's do another one. So now this time they gave you body temperature, and they say use a 5% significance level to test the common belief that the population mean is 98.6. So they gave you X bar, they gave you S, they gave you N, and they want to say that the population mean is 98.6. So you have null hypothesis, alternative hypothesis. Then you would say mu equal to, that's for null, What is the alternative in this case? Is it less, more, or not equal to? So the common belief that the population mean is 98.6. Good, because they didn't mention less or more, then alternative to equality is inequality. So they just say equality where the equality goes in the no always. So the alternative to that is not equality. And then another reason is because they didn't mention greater or less.
Do we have to write mu with the X bar?
Mu is for population, X bar is for sample.
All right, because the notation you gave us earlier was mu with the X bar equal
Oh,
population.
mu of X bar is the same thing as mu.
Okay.
That means average and population average using X bars, using samples. Yeah, but these two are the same. Like mu of X bar is the same thing as mu. But X bar itself is sample mean. Make sense?
Yep.
Okay, good. So now let's just put this into your calculator. So sigma is unknown, so still you use t-test. So step one was this. Um, Step two is a requirement. We assume I don't have the actual appendix for this one. If either n is greater than 30 or normally distributed. So we assume that's met. Let's go to the third step. So I want you to use t-test because sigma is unknown. We may not do examples much with sigma known because it's not commonly used. But again, if sigma, or maybe I pick something from the textbook later, but sigma is again unknown. So you use t-test. Okay, so use t-test. Tell me what is p-value. So put this data in your calculator. Tell me what you get. Tell me what is the p-value you get. So this time, so I see one answer so far, or two. Please send more. This is just putting it in t-test. And then if you don't do it with me, it's very difficult to learn it later. So, oh, n is 106. We say n greater than 30 is good. So then do you see n is 106? So that's met, the requirement. So you go to the calculator, stat, test. Just keep in mind that I know the material. You need to learn it, so do it with me. So you go to t-test. This time you have the stat of the number, not L1, but the stat of the number. So mu, the null hypothesis, we wrote down was 98.6. So 98.6. What was X bar? So grab it up.
98.2.
98.2. What is S sub X or S? Sample standard deviation?
0.62.
0.62. And then how many, what is n?
106.
Which is greater than 30. Great. And then you're saying exactly 98.6, which opposite of that would be inequality. And then you go ahead and calculate. Okay, 1.4 e to power negative 9. This part is important. What is this equal to? What is this number?
0, essentially.
Exactly. So you would say it's e to power negative 9, means I take the decimal place and I go backward 9 places. So that means I have 8 zeros after decimal. And then 1403 7 if I'm rounding it after 3, if I round it to here. So with so many zeros, this is almost 0. It's a small p-value regardless what you're comparing with. So then you reject a null and you support alt. So you would say there is enough evidence to warrant rejection of the null. So let me just go to the wording of the book. So Shelby, give me a minute. Let me just finish this one and I answer your question next. So for the conclusion, we would say there is enough evidence to warrant rejection of the body temperature. Here we go. So there is sufficient evidence to warrant rejection of the common belief that population mean is 98.6. Anytime you are dealing with inequality, as you saw on the table yesterday, we say we warrant rejection of whatever is the situation. If P is small, we say there is enough evidence to warrant rejection. Or if P is big, then we say there is not enough evidence, exactly like before. Okay. So, Shelby, you asked me a question about calculators. Say it again. What is the question? You said after clicking test, we have options for one sample, two sample. So you're using one sample because you have one sample. So you have, I'm not sure what calculator you have, but if you have this one, you have t-test. Later on, like in the next chapter, we're going to talk about two samples. But right now, it's just one sample, and that's t-test. Okay. Any questions? Let's see if you have another example in the PowerPoint. Okay, here we go. So I want you to do this. Listed below is a random sample of times, seconds of tobacco use in animated children movies. Use a 0.05 significance level to test the claim that the sample is from a population with a mean greater than 60 seconds. Since these are 60, use 60. So what I want you to do, I want you to write null hypothesis, alternative hypothesis. Let's that. 2, assume that the requirement is met. 3, use t-test and send me p-value. And then 4, write a conclusion. So let's just start from the first one. Write a new hypothesis, alternative hypothesis. So I want you to start with new hypothesis, alternative hypothesis. Always use the last sentence to form it. Since it's about average, you would say mu equal to, and then in this case is mu greater, so mu greater than 60 seconds or mu equal to 60. Mu equal to 60 seconds, mu greater than 60. So now I want you to use t-test. Put this one in L1. Tobacco use in animated children's movie. And see if the population mean for that is greater than 1 minute. Send me the p-value you get. And again, please do it. You will not learn. Basically, it's waste of time if you're coming here and you're not participating or doing the work. So I want you to put this in L1, use t-test, find p-value, and then send the p-value to me via chat. So I give you a few minutes. Send it to me and I will confirm the answers at the end. Okay, great job to those who are sending it. So put it in L1. Check your L1, everyone. Make sure you put it right correctly. Put it in L1. Use t-test and find the p-value. So I give you 2 minutes for that. Choose the option of greater because it says greater than 60 seconds. Okay, I'm receiving some answers. Any more? Okay. So I'm getting different answers from different people. Let's see who is right. I don't have the answer in front of me. So you put everything in L1. So let's go do it one more time. So you go to stat, you go to L1, you go to second, clear down. Okay, and the numbers. Can someone please read the numbers to me?
Zero,
Uh-huh.
51,
Oh, 51. Okay.
223,
Mm-hmm.
000,
000
176,
176.
0,
Uh-huh.
548,
548.
0,
0.
37,
Uh-huh.
158,
158.
299,
299.
37,
37. Uh-huh.
0,
0.
11, and then 0000.
How many zeros? 000.
Or
There were 20 numbers.
yes.
Okay, thank you very much. Okay, you go to stat, test, t-test. You go to data. Because you put in an L1, you go to data. And then for mu naught, you had whatever was your claim here. Was it saying that it's more than 60 seconds, right?
Mm-hmm.
Okay, so more is the third option. More. And then you go ahead and calculate. 0.2999 is about zero point 0.3. So you would say this is about zero point 0.3. It's a large p-value. So you fail to reject a null. And do not support alt. So here we go. There is not enough evidence to support. There is not, because we say fail to reject. There is not enough evidence to support that the tobacco scenes are more than 60 seconds. That the tobacco scenes are more than 60 seconds in animated children's movie. Okay, so let's go to the PowerPoint. there's not sufficient evidence to support that the mean is more than 60 seconds. Okay, that's all. So now let's take 5 minutes break. When you come back, we're going to start 9.1. And that's going to be about more of testing and um, also intervals. So when you come back, let me pause. Okay, let's go to module 9. Let me close this one. Calculator is fine. OneNote is fine. Okay. So watch the videos. It's going to help you before doing the homework. So now you have some idea of testing. In chapter 7, you got ideas about interval. In chapter 9, you're going to talk about multiple population, two populations, proportion, and two population mean. Today, we're going to talk about two proportion. I put two examples here, videos, one for two proportion z test and one for two proportion z interval. So please watch them. And the homework is already up. 8, the things that I taught yesterday are due tonight on my math lab. And 9.1 and 8.3 are due on Sunday night. So keep track of the math lab work. And then complete the worksheet, but it's not going to be due until next week. Okay, two proportions. So two main concepts in this section. One, testing a claim made about two population proportion. And then two is constructing a confidence interval, estimate of the difference between two population proportion. So these are the two main ideas. Please write them down as we will be using and going over the two concepts. One, testing a claim made about two population proportion. When you have two population, comparing population of men and women, population of let's say people who live in United States versus people who live in Mexico. Um, two population, you are comparing population of weight of apples, certain apples versus another kinds of apple. So comparing two population on any claim you made about proportion. Okay, constructing confidence interval, the one that we say we are 90% confident or we are 95% confident and so forth. Okay, let's just, here are the objectives: hypothesis test and confidence interval. Same as the past, P1 population proportion, of course, for the first population. P hat is sample proportion, N is the size of the sample, Q is the complement of P, X is the success of the first sample. And then the same thing would be for the second. Maybe quickly write the notations. We had used them in the past, but This time it has a sub of 1 and sub of 2, means for the first population versus the second population. For the pooled sample, we use our calculator. We don't need it much. But if you add the successes of the first and second population, sample, and divide by add of the sample sizes, then that's going to be pooled proportion. So write down the formula. I may use it somewhere along. So pooled sample proportion is the formula: addition of the x's over addition of the n's. Oops. What happened? Here we go. I'm going to give you an example of calculating the pooled sample. Exactly like before, this must be a simple random sample. You're talking about proportion. They must be independent. At least 5 success and 5 failure for each of the samples. Anytime you're talking about proportion, you're talking about a binomial distribution. So it must be fixed number of trials, it must be independent, and then you have to have 5 success and 5 failure. Okay. So let's go to an example. We will be using our calculators. So anytime you're talking about null hypothesis, you're talking about equality. So you say P1 equal to P2. And then because you are comparing the two population, the alternative to that would be either the first one greater than the second one, less than the second one, or not equal to the second one. Okay. Connecticut and New York. Can I have a volunteer to read this example? And then I'm going to give you a calculator command to do it. May I have a volunteer here?
I'll read.
Thank you, Andrew. Go ahead.
Example, proportion of cars with rear license plates only. Connecticut and New York are contiguous states, both having laws that require front and rear license plates. The proportion of Connecticut illegal cars with rear license plates only is 239 over 2,049, or 11.7%. The proportion of New York illegal cars with rear license plates only is 9 over 550, or 1.6%. The
Mhm.
sample percentages of 11.7% and 1.6% are obviously different, but are they significantly different?
Thank you. So you want to know if you're comparing the proportion of illegal cars having rare license plates only in Connecticut and New York compared. You want to know if they are different or not. So no hypothesis, step 1. No hypothesis, alternative hypothesis. No hypothesis is saying that their proportion are equal to each other. So always null is equality. And then alternative in this case, what is alternative? Greater, less, or not equal to? Since it says different, it doesn't say more, it doesn't say less. So you use not equal to. Okay. With the first population, what is X1? So I need you to list these. What do you think is X1? What is N1? What is X2? What is N2? So let's put that as a step 2 because it helps us um, with the requirement. X1, let's say if Connecticut illegal cars are the first population. So X1 would be 239 success, arbitrary success, 2049. So that's more than 5. And failure are those who are not illegal. So it's the difference of these two is again greater than 5. X2 is 9. 9 cars are illegal in New York out of 550. That's greater than 5. But then also the failure, which is the remaining that are not illegal, is 550 minus 9. That's greater than 5 too. So are we set for this part? Step 3, now we want to use the calculator command and we want to we want to find p-value. So the calculator command, I want you to find it. It's about proportion of two population and you're testing. So let's go to the calculator. So you need to realize at this point on that what calculator command to use. So you go to stat, go to test. Which one do you think would be the one we are using here? Please send me a chat that which one of the list on the test I'm using here. I have 2 population and I'm testing and it's about proportion. So which one is the answer? Again, if you are here, very good. So far, all right answers. Eli, that's right. Shelby, that's right. Andrew, it's right. Oh, actually, Eli, look again. Um, Mindamola, that's right. Okay, so you have 2 population. Great job, those who answered. You have 2 population proportion. And then that's a testing. It's not interval, so you use 2 prop z-test. X1, N1, X2, N2. I think I remember it. X2 was 9 out of 550. So what was X1 out of? Let's fill it in. So let's put the data in here. So let me go back to the PowerPoint. 239 out of 2049. 239 out of 2049. And in this case, you just go that they are different. So please see if you have matching numbers on your calculator. Should we move on? Let's go and say enter. P1 is not equal to P2. What is happening here? With e to power negative 12 means I go backward 12 places, means I'm going to have 11 zeros. So this is about 0. So the p-value is about 0. Do you see that this is our null hypothesis, alternative hypothesis matching? So p-values is small, so you reject the null. So you reject the null. You would say there is enough evidence to support or to warrant rejection that the two population proportion is the same. That the two population proportion is the same. So I'd like you to write what are those two population proportion. You can explain that the proportion of illegal. So this means that the proportion of illegal. So because you are supporting the alternative, the proportion of illegal plates in New York is different than Connecticut. Is different because there is enough evidence to reject the null and support alt, and alt is that they are different. So you're supporting that they are different. Okay, so let's just, they did the calculation manually as they will do it, but then we do our with your calculator. And here we go. So what did they get for the p-value? Almost zero, the way we did. And then here we go. So there is sufficient evidence to conclude, somewhere in the middle if you find it, there is sufficient evidence to conclude that they have different proportions of cars with license plates only, or the proportion of illegal cars are different. Again, because we are rejecting the null and we are supporting the alternative, and alternative was that the two are different. So you are supporting that. Okay. So let's do another example. Now it says use the same sample data given to construct a 95% confidence interval estimate of difference between the two population proportion. Does that result suggest about the claim that Connecticut and New York have the same proportion of cars with illegal license plates only? Okay, so now you want to construct a confidence interval. So 95% confidence interval. Use your calculator. Go to stat, test. Tell me now you want to find the interval and you have two population proportion. Which of the items you use throughout the calculator under tests? Tell me which one is appropriate for the interval of two population, because you're still comparing population of illegal cars in Connecticut with New York. Which number would that be? Randomala, you got it right the second time. You are talking about two proportion and you are looking for interval. Two proportion and interval. I don't want you to memorize these. I want you to read your calculator and say, oh, I'm using this. Two proportion and interval. Okay, great. So now let's go to 2 prop z interval. That was 2 prop z test because you were testing. Now you want to find interval, you use interval. This is a confidence interval. Okay. So now you have x1, n1, x2, n2. They said with 95% confidence interval. So they specifically ask for 95%. And again, because this one was, to repeat myself, because alpha was 5% here, and this was not equality. We said P1 not equal to P2 is two-tailed. So we just say 1 minus alpha, so it's 1 minus 0.05, and that's 0.95. Even if they were not saying with 95%, we would have known. If that was one tail, then you would have say 1 minus 2 alpha. But since it's two tails, you would say 1 minus alpha. Okay, so let's go ahead and calculate. The interval, so you would say we are 95% confident that the difference in population proportion of illegal plates or illegal cars. In which one was our first population? Was Connecticut, I think. Illegal cars in Connecticut versus New York is falling between 0.0828 and 0.11776. So let's say, what is that? So P1 minus P2. When we are comparing, we would say the difference falls between here to here. P1 was Connecticut, P2 was New York, right? Am I right? Just check and see. 9 out of 550 was New York, or 9 out of 550 was Connecticut?
It was New York. 9 out of 550 is New York.
Okay, then I have it right. Okay, good. So the difference of the two, it's all positive numbers. Do you see the difference is all positive number? If I get a positive number, this is greater and this one is less. Do you agree? If I difference of two numbers becomes positive, do you agree that the first one is a greater number? So that's why you know that P1 is definitely significantly higher than P2. And then since there is no zero, then that's guaranteeing that the two population proportion are different. If in this interval I had zero somewhere, if this was negative and then positive and zero was somewhere here, then you would have known, oh, P1 minus P2 at some point is zero, so they are equal. But you don't have zero here, so that means they're always different. So that's sort of back up your testing because zero is not in there. So zero, not in interval. So that's guaranteeing that P1 is different than P2. Any question?
Yeah, I kind of don't know what you just mean by what you said.
By the zero?
Yeah.
So the interval here is the difference of P1 minus P2. That's what the 2 prop z int is.
And we
So
have
the
to do that
interval,
whenever we do. We have to do that P1 minus P2 every time we do a two prop interval.
yeah, and any interval you get as a result of 2 prop z interval is representing p1 minus p2.
All right.
Okay, do you see 0 in this interval or no? It starts as a number line. If 0 is here, 0.008 is a number close to 0 but not 0, going all the way to 0.111 somewhere here. So here is the interval. Is the 0 in that interval?
No.
No. So if zero was in the interval, then that means p1 minus p2 was 0. That when two numbers, their difference is 0, means they are equal to each other. Means p1 should have been equal to p2. In this case, 0 is not, so that means they are never 0. So they are never equal to each other. So that's guaranteeing that the proportions are different. Make sense?
Okay.
Because
Yeah.
0 is not in the interval, so it guarantees that p1 and p2 are always different because 0 is not in the interval. So that guarantees that they are different. And that's supporting our claim that the proportion of illegal cars in New York and Connecticut are different. Any other questions? And as you do the homework, the good thing about the online homework is asking you like a step by step of um, like what does this mean? Is 0 in that interval? So then they are not equal to each other. If the 0 is there, oh, then they are equal, and so forth. Okay, so let's see. Let's just close this one. What I want you to do for the time we have, I want you to open up to my math lab. Go to my math lab. And let's get us started with some of the 9.1 homework. So 9.1 is already up. Instead of picking questions from the textbook, I would say just go to my math lab. Go to assignments. Do you see 8.1, 8.2 are due tonight? 8.3, 9.1 are due Sunday night. Let's just click on 9.1 and pick some of the questions. Have paper and pencil ready. So I want you to list for yourself x1, n1, x2, n2. Sorry, sometimes my pen acts up. P1 hat is x over n. P2 hat is the sample, so it's x2 over n2, and then so forth. So answer every part. And when it gets to the pooled P, add x1 and x2 and then divided by n1 plus n2, so on and so forth. Let's just do number 2 together. I want you to do it, and then if you get two problems, I help you. So let me stop recording right here. It's more of so.